Tie-dye Tuesdays, just so you know. Every Tuesday. Or, no, I'm not wearing tie-dye underneath. That's weird. Okay, so today we're going to check the homework first because I immediately forgot about it when people mentioned it. So there's going to be an awkward pause here, which really wouldn't be awkward unless I mentioned it because how would they ever... Now, after the pause there, I don't remember what the cliffhanger was to make a joke out of it. Today, we get 2 new rules. And normally what I do is I present a rule and then we do a bunch of examples with said rule. And then I do another rule and we do a bunch of examples with said rule. I'm going to switch it a little bit. Today, we're going to get 2 new rules right off the bat. And then we'll have to make sense of which rule do we use in each context. Okay. Travelers, cannot stress it enough. I did talk about making an assignment for notes yesterday, right? If you guys happen to have your study hall time line up with this class and you want to like Google Meets in, please let me know. I will invite you. We get some, like, there's not many days where I wouldn't be able to say we do some like fundamental stuff, but tomorrow and the next day is probably some of the most fundamental stuff that we'll see. Tomorrow's a work day, so I guess that's Monday and Tuesday. But please watch a video. Please send me emails with questions. And everybody, for that matter, don't like just coast by on this. If there's anything that doesn't make sense, we have to address it right here, right now. Cool. All right. So we get 2 new rules today, and we're actually going to start 2.4. And the 2 new rules that we get out of 2.4 are going to be the product rule and the quotient rule. So what I'm going to do, so it's not redundant, I'm going to say 2 new derivative rules. Okay. One of them we sing, one of them we don't. And you could probably sing all of them realistically. And it's not going to be like hardcore singing, but there's a dumb thing that helps me remember it that I've watched it help a lot of people remember. If you don't want to sing it outside of today, you don't have to. Cool. Guarantee you all will. I'm pretty sure of it. I'll hear it during tests. Okay, so to start us off, the 2 new rules. And again, it's going to be strange because we're getting the rules in a ton of examples. The first of these is what we call the product rule. Okay. I am on the fence whether or not I want to prove this one or not. We could, and it's not wildly hard to prove. We'll see if we wind up doing it. But here we go. We're going to define a new function. So we're going to say let, and I'm going to use p of x with the understanding that your book uses a capital F. And we will use capital F's later, and it's odd to use capital and lowercase f in the same problem. I'm trying to avoid it. We're going to let p of x be the product of 2 functions. So let's say we define some function, p, as f of x times g of x. Okay. Now, as we go through this, we have a new function defined. We're going to say that with this, we'll just specify where f of x and g of x are both differentiable, and I'm going to write this one time, and then I'm going to suggest a shorthand. Differentiable, which means I can do what to it? We can take the derivative of it. You will likely see me write it again many times, but my shorthand for differentiable is a Holloway contraction. Diff bull. The erentia part of it is what I leave off. I make up my own contractions. It shows up so much, it's worth it. Differentiable, diffable. Okay. When we have 2 differentiable functions, here is our rule, and we're going to write it out. This is not our sing-songy one, so you still got time to warm up your voice if needed. Here we go. To take and find, and we're going to write it 2 ways. First way is if we want to write it using this lovely prime notation, p prime of x. Okay. I'm going to write it out, and I'm going to ask you guys to help me come up with the wording for it. Here it is. P prime of x is exactly this. It is f of x times g prime of x plus g of x times f prime of x. Now, I don't want to commit a ton to memorizing it, but I want you guys to come up with, I'm going to do like 60 seconds, talk with your neighbors, come up with a phrase that explains this rule. I know how I do it, I know how I'm going to show you how to do it, but I'm hopeful that somebody has a better way than I do it. Cool. 60 seconds, how would you describe this? What's going on? a way to remember it is all I'm after. 60 seconds, as soon as I find my timer, we'll pause the video. Okay, so I won't do that again in hindsight. Do you agree that we have two functions that are multiplying? Okay. I have a first function and a second function. The way that I refer to this every time, and it's wordy, we're going to write it once. I'm going to make you guys say it like 5 times. Because if we just say it 5 times, like boom, 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 it's more likely to stick. To find this derivative, p prime, it is the first, which, what was our first function? Here. It's f, right? That's our first function. So we do first times the, times the derivative of which function? The second. And do we all agree that that's what the first part says? First times the derivative of the second. That's f times g prime. Okay. Plus, how would you, using this kind of now setup, how would you describe the second part of this? The second times the derivative of which one? The derivative of the first. Okay. Over and over and over, you will hear this referenced over the next several months. First times the derivative of the second plus the second times the derivative of the first. They just flip-flop. Okay. Whether I make you say it 5 times fast or we just make you say it 5 times throughout the lesson, doesn't really matter. What is the product rule for derivatives? Okay, does everybody have it memorized? Okay, let's go one more. First times the derivative of the second plus the second. All right, so first time we've played this game this year. We will do examples with these here in a couple minutes. Now, we could extend it, and we don't want to extend it all the time. We could do f times g times h. It'd be first times second times the derivative of the third plus first derivative of the second. We just shift it. Okay. As we go through here, everybody be prepared. I'm going to write this next one right here, and then we're going to have to make the decision as to which rule are we using. I really want to prove this. We're not going to physically prove it, but I'm going to show you the proof. And just so you can see what kind of calculus proofs look like, they're not 2-column, never. They're not induction proofs most of the time. I love induction proofs. If you guys remember, assume k, we must show k plus 1. Those are my favorite types of proofs to write. For this proof, how do we define a derivative? Ooh. It's the slope of the tangent line. That's a conceptual definition. What about the mathematical definition? It's a limit, right? And if we're talking about a function, it's usually the f of x plus h1. Okay, so to do this proof, and again, never going to make you write a proof, but it's my hope that you guys can at least follow what's happening. So notice, I wasn't sure if I wanted to do it. If we're trying to find this derivative, I'm going to take f of x plus h, and I've done it differently, but here's f times g of x plus h minus f of x times g of x, because it's a product, over h. We then expand it, and like we get this goofy thing. We can add a 0. And it looks weird, and it is weird, but I can add this as my 0, f of x plus h times g, and minus f of x plus h times g. Coming up with that choice is challenging. Like, unless you're actually proving it, you probably would not come up with it. But we can all accept, I imagine, that I can add 0. I add my 0 in right here, and I can see it. Now, if I forget everything else, just with these two, is there anything that can factor out? I could factor out f of x plus h, and it would leave this behind. Out of these two, I could factor out my g of x, and it leaves this behind. When I split it up, because I've done that, I notice that here I have f of x plus h times g of x plus h minus g of x over h. If we forget about that x plus h, and I just take this limit, does this look exactly like the definition of a derivative? So I replace this with g prime. This one, same thing. I can imagine it, h is just on these, and this looks like the derivative of f, and here it is. Completely proven, shown. The adding 0 part is a very hard thing to come up with if it's just you doing it, but there's the proof. You do not have to prove it, but it's nice to see them. All right. We get a new rule, and we're going to get sing-songy with it. We have the product rule as our first one. We also get the quotient rule. Okay. For the quotient rule, we're going to do something very similar. I'm going to use q of x instead of p for quotient. And let's define a function real quick. We're going to let q of x be equal to some quotient. And we'll call it f of x over g of x. Okay, first thing, is there a low function on this? Like if I talk about the lower function and the high function, can you tell me what I'm talking about? Here. Like physical location, what's low? So low is g of x, right? Match me. Low. You can be an octave higher and still hit the same note. Okay, cool. Low. Okay, this one is the what function? How are we going to sing-songy this one? High. Yeah, for real. Low. High. We're going to hit both of them. And it's going to sound terrible, but I guarantee once we get this, we'll be sitting here doing a quiz, a test, and I'll hear somebody go, and like I'll hear it. I will physically and like actually hear it. Okay, as we go through this, here's our function. We have a clear low and a clear high. Okay, where f and g are both differentiable. Where f, comma, g are differentiable. Okay, and I'll add my apostrophe. Two differentiable functions, we have it worked out. Here we go. If we want to find this, and I wrote 1 here, expecting to write 2. I'm not going to write 2. It's just with a ddx instead of prime stuff. We're going to use ddx on this one here. Cool. So here we go. If we wanted to take q prime of x, I already just changed gears. If you guys already have q prime, we're going to use prime notation instead because I immediately did the opposite of what I said I was going to do. All right. Check it out. What's the low function? So low. And then this part, I am going to switch back to the ddx because it looks nicer for our song. ddx, that means the derivative, right? Low, d, high. Can everybody give me a good low, d, high? Low, d, high. We're just going to hit it. Cool. Everybody can do low, D, high. Okay. Minus high, D, low. What's my low? G of x. All right, so we're just going to hit that first little part. There's clearly a fraction coming if I didn't preface that. Okay. In sing-songy. Low, D, high, minus high, D, low. Are we all going to come in?
3, 2, 1,
Low, D, high, minus high, D, low. Low, D, high, minus high, D, low. Oh, do it. Low, D, high, minus high, D, low. All right, we're ready for an awkward eye contact game yet, or are we going to have the very last piece? Sounds like we get a volunteer. All right, check it out. We're not quite done. Low, D, high, minus high, D, low. This part doesn't work really great, but it kind of does. Ready for our last little lick? All over low squared. Okay. All over low squared. Boom. Low, D, high, minus high, D, low. All over low squared. It's so dumb. I'm okay with it. I'm good with it being dumb if it means it sticks in your head. If you want the lyrics, I got you. Low, D, high. Hold on, here. Ooh. Low, D, high. I'm not really going to transcribe the music. I'm making it up, right? A G. right? This is a G, everybody?
That's a low G.
G, A, B, C, D, E, F sharp. It's really F, but we use F sharp with our scale, right? You're a saxophone player? Same thing. Okay. All right. Low D high, minus what? Minus high, D low. And I'm going to write it like this, so it looks like a derivative operator. All over, low squared. Okay, it's so silly, and I get it. But if you're going to mess up a derivative rule, at least to begin with, it's probably this one. The product's reasonably easy. You could probably do it first, D second. No, I'm not even going to try. This one's the sing-songy one. Okay. What's the song? How do we sing it? Okay, so we will be sing-songing and awkward eye contacting. I want to get a problem of each first. Tomorrow, travelers, you should watch a video. It's nothing but examples. Okay, now, examples in work. So here we go. I'm not going to tell you which rule we need. Does everybody have these two available on your page? You can see them both. Cool. All right, so examples. In these examples, we're going to do two things. I want us to find f prime, but to do that, we need to be able to identify which rule we're going to use. Now, the weird part about this, and maybe it's not that weird, later maybe we'll see that multiplication and division, they're not really different, right? They're the same operation. It's why we can say GEMS instead of PEMDAS. Multiplying and dividing, they're the same thing, just upside down or backward, however you want to think about it. Does that idea sit okay with everybody? So maybe we can use product rule in cases where quotient rule would be applied, but today we're going to state the rule and find the derivative. And I won't try to throw anything crazy. I lied. We're going to do one physics one, so I'll have one that's d dt, but derivative. So here we go. Our first one. On A, we are given that y as a function is defined to be e to the x over 3x plus 1. It's awful. I have no idea what the graph looks like. Couldn't even begin to tell you, other than I know it has a vertical asymptote at negative 1/3. That's all I know about this graph. Okay, don't need to know anything about the graph. Not at all. First thing, do we have product or quotient? Quotient. And by God, if only there were a song that helped me remember the quotient rule. Low. So let's pause. I love it, by the way. What's low here? So low. And you don't have to physically do this every time, but I'm going to write them out this time. If this is low, it means this is what? High. Okay. We have two very easily identifiable pieces, right? The lower piece and the higher piece. So whether we use F or G doesn't matter. Don't care what they are. Let's run through this. If I want to find the derivative of this, and we're going to jump right in, y equals low. What do I write first for low?
3x.
Love it. 3x plus 1. So we have low. What's next? D high. So derivative of the top. Now, we're going to do this longer writing today. Do you agree that derivative of the top does look like this? Low D high is exactly what I have written here. Minus high. And what's our high function? E to the x. D low. I'm going to switch to red. D dx. What's the low function? 3x plus 1. And this is all over low squared. I'm okay with, I was getting the answer, I could hear it. Low squared, right? Low d high minus high d low all over low squared. So I'm going to put a 3x plus 1 and I'll square it. Are you asking me to prove it? So it's not a threat. Oh, I don't know. Humans are weird. How many of you remember the Constitution? Every word of it. I'm sure you've read. Have you read every word of the Constitution? Our Father who art. Nah, I don't know it. We the people of these United States, in order to form a more perfect union, something like that. I don't know. I'm sure I read it once. I don't remember it. But if you ask me any song that I've listened to like 10 times at any point in my life, I bet I can remember the words. And I bet you guys remember the words to lots of songs. I don't know what it is about humans and sing-songy stuff, but it helps, legitimately. Who reads the alphabet? A, B, C, D, E, F. No, I don't think you really know the alphabet. You just happen to remember songs because you're human beings. Anybody ever not go A, B, C, D, E? Everybody sings it, right? There's a reason we teach kids the alphabet and singing it. Humans are good at that. I don't know why. That's a very interesting question. No idea. All right. Now, realistically, this is the work that should go into this problem. This is it. Now we actually need to do it. Some of you may be tempted and can even do so correctly. I'm going to write prime here because I had forgotten that. That is y prime. But I bet we can work this out pretty nicely. I'm going to do little steps. High is here, and here's the big moment. What's the derivative of e to the x? That's pretty convenient. Notice me not foiling anything out yet. Here's low d high, and now I'm going to minus high d low, and here's my high function, e to the x. What is the derivative of 3x plus 1? I write it here. Naturally, I want to put it here instead, but I'm going to write it there for now. All over, am I going to square it out actually? Not a chance. Not a chance yet. If I have to, I will. I'm going to keep it 3x plus 1 squared. I'm not going to multiply it. Why would I waste the time? Okay, as we look at this, right off the bat, simplified derivatives are never necessary, depending on what you're doing. Just if I say find a derivative, do we have a derivative? Like there's no more d dx left. I've done everything. This is legitimately the derivative. Is there any obvious algebra that we could do to clean it up? If I factor out e to the x, and I'm just going to use one color here. I'm going to quit switching. E to the x times, what's left here? So before I write it, I agree, 3x plus 1 minus 3, right? Can I combine 1 and minus 3? 3x minus 2. I just distributed and simplified over 3x plus 1, or my low squared. Cool. We have successfully just found our first kind of ugly derivative. Now, if you have the rule memorized, is that really any harder than stuff that we've been doing? It's longer, 100%. It's a longer problem because it's a uglier, more gross function, but it is not really any different than what we've been doing, just with more steps. Now, you guys can start packing up, but I do want to point you in the direction of something that we're finally, maybe just mathematically savvy enough to deal with. Tomorrow, you don't have to start this homework tonight. You can, but we are going to do a bunch of problems tomorrow. On YouTube, if you guys are bored at the airport, you have YouTube Premium or a way to download it. Here's what I would suggest you all check out, because this guy is awesome. Search up 3 brown, 1 blue, the essence of calculus. Not calculs, but this is the best popular math stuff that you'll ever find. His voice is like butter, like fantastic, just to really drive that home. You guys can obviously keep going. You don't have to listen to me. Volleyballers, good luck. I imagine that we will be listening to the games. Weird. All right. Peace out, Raiders. Tomorrow, come ready to work. Come with $5 American, so you can wear a hat. And travel well, play well, reach out with questions, watch your videos. Cool. Later, Raiders.